Yeah, so the research of our research section can be distinguished in three research themes. So the first one is a dynamic of material and equipment interaction. Basically, this theme concerns about the design and the dynamics during the material handling, just like to handle the dry bulk material like coal or iron ore, but mostly we do the handling of containers. As you know, the maritime industry in Netherlands is very advanced. Then the second research theme is the intelligent control for transport technology. That means we want to control the transport at a system level instead of equipment level by means of artificial intelligence. Then the highest level is the research regarding real-time coordination for logistics. That means that the control concern about the large-scale transport system and also logistic processes. So at this moment, mainly I would say I'm in charge of the second research team regarding the intelligent control for transport systems. So as I said, I would like to quickly introduce the AVATAR project, which is ongoing within our research section. So AVATAR stands for the autonomous vessel, cost-effective transshipment and the waste return. So basically, the goal is to solve the last mile freight distribution problems by means of the transition from the road transport to water transport to achieve the sustainable urban transport. So here, I just mentioned a few motivations of this project. So maybe we know for most of a lot of European countries or cities, there are large-scale waterway network. And originally, those waterway networks are built for the cargo transport. But nowadays, we are facing more and more challenges for the last mile distribution for the freight. But this moment, the conventional waterway is underutilized. And also specifically, lots of freight transports are done by the road transport by trucks. Then we face lots of traffic jams, the road congestion, and also the competition of different companies are increasing. And also we are facing the sustainable issues during the large scale and the long distance transport, and also for the last mile deliverable. So that's the reason we proposed this AVATAR project to try to tackle the challenges to develop the zero-emission autonomous shipping for the inland waterway transport. And also later on, we want to test and assess the performance of those autonomous ships. So here you see the long list of the project partner. Actually, the total budget of this project is almost more than 2 million euro within 2.5 years. So basically, the research will be carried out by 3 universities, as the Delft University of Technology in Netherlands, and the University of Leuven in Belgium, and the University of Oldenburg in Germany, with the support from government and quite a lot industry applications and also companies. So actually, this project is kind of European Interact project aimed to the North Sea region. And it's kind of a co-financed project. And the main aim of the project is to develop several aspects regarding the prototype of the autonomous ships and also realize the remote monitoring and control of the autonomous ships. then to develop the business cases and the use cases in urban environments. So regarding the business case, we will analyze the political and the legal framework to apply the ship units in the regions, including Ghent, Leuven, Delft, and Hamburg, in those 3 countries. And the most important stage is the final phase of this project. We are going to perform the pilot tests in those regions. So if we think about the future of this project regarding the testing, operation, and assessment of the autonomous ships, we can distinguish the whole process as 3 steps. The first one is to develop the pilot scale autonomous ship, then to run it on site. So far, the University of Leuven has already developed one semi-full scale 1-ton vessel and already implemented in the area of Leuven. So based on this 1-ton pilot scale vessel, we are testing the different monitoring system, different sensor technology, and onboard computer and control system by means of intelligent control. Then for the full scale, that's ongoing step at this moment. So we are building the new vessel with capacity of 20 tons. And since October, the main body of the ship is started to be built in the shipyard in Netherlands. And afterwards, the hull of the ship will be transported to Ghent and to be integrated with the fully electronic drive system to realize the zero-emission vessel. And later on, for the testing and the operation, the experience and the technology we tested by the company of Seafar and based on the Maverick vessel will be implemented on this full-scale vessel. But actually, so far, we just see the application or implementation for the individual vessels. But if we think about the real application, we will face the multiple autonomous ships in the urban transport environment. So that's also the reason we are, as a Delft University, we are working on the research of monitoring and control of multiple autonomous ships. At this moment, we have the research lab of autonomous shipping with a fleet of model scale vessels, which are used to test and implement the fleet of ships. And together with the University of Oldenburg in Germany, we are building the remote monitoring and control and data communication system regarding the interaction between vessels and the interaction between vessel and the shore sites to realize the project. So as I'm from the University of Technology, Delft University. So following, I would like to give you a quick view about our main research of the RAS lab, the research lab of autonomous shipping, and to show you some current development and experiments we have already done. So basically, the RAS lab aims to the research, development, and realization of autonomous shipping in the urban, not only for the urban transport and also for the maritime transport. But the project of Avatar aims to the urban inland transport. And besides this kind of research and development, the most important thing for us is the application site we can use to test the autonomous shipping and also to do the experiments regarding the monitoring, communication, and the control of the overall system in diverse environments. So here, that's the overview of our existing lab facilities. So we have the laboratory of autonomous shipping, we have the flume tank and also towing tank. And the towing tank contains two parts. The bigger part, we have the towing tank with a total length of 50 meters. And the smaller one has the length of 20 meters. And the right bottom side, you see the green village. That's one part within our campus. And this green village is surrounded by a canal. So based on this site, we can run our autonomous ships in the canal and from the remote control located in the village. And for the ships, so far we have already developed 3 generations of model scale autonomous ships. So here we see the first generation is the tugboat. And the length of this boat is almost 1.5 meters and equipped with different type of sensors. Then the communication between the ship and the control center is realized by the Wi-Fi and also the radio frequency. So mainly this tugboat was used to test the control regarding the autonomous dynamic positioning. Then the second generation is the gray Seabax. It's a 130 scale offshore ship. More or less, the configuration of the ship is similar as the tugboat, but we added the camera as the extra monitoring facility, and also we have more intelligent control system to realize the remote control for the ship. Then the second generation of the ship is a fleet of model scale ships. At this moment, we have a fleet of a ship contains 20 individual ships, which we are using them for testing the distributed control for the multiple vessels. So here we have the overview of the current research in the RUS lab. So that means based on the lab facility and also the development, we are realizing the control for both individual ship and multiple ships regarding the monitoring, communication, coordination of the ship. And besides the control of ships, we also take the surrounding transport and the logistic process into account. And based on the interaction between the human and the machine, and also development of the middleware of the control system, as I mentioned again, the most important thing is to validate the control system and algorithms based on experiments. By taking the simulation results, real-life data, and the performance of model-scale vessels into account. Just like here, we see the middleware of the overall control system. We developed the system from the data acquisition to the automatic identification of vessels for tracing and tracking, and to build the large-scale communication network, and followed by the data analysis, then to achieve the intelligent operational decision making. So here we see one example of the control for individual ships. So actually this this part of the research is based on the collaboration between University of Delft the government of Amsterdam and also the MIT University in the United States, based on their robots developed together. So for this individual ship control, we apply the model predictive control to predict both the maneuvering of the ship and also the thrust or location by taking the energy consumption into account. And here we see something about control for multiple ships. So also based on the cooperative control and the model predictive control, we are trying to realize the large-scale control for multiple ships within the city waterway transport, and also to realize the collaboration in between vessels and between vessel to infrastructure or the shore sites. And another important thing is we are going to achieve the control for the sailing information for regarding the energy consumption or the fuel efficiency. Just like on the right figure, we see the vessel twin, or another term is the platooning of the vessels, based on the leader and follower principle to improve or optimize the control of the fleet of the autonomous ships. And to validate the control system and also the model for the control, we developed the integration methods in different operational scenarios and operating environments by taking the autonomous shaping operation and the human controlled operation and also the simulation and the model outputs for the experiment and the validation for the control system. And if necessary, we will also take the regulation or rules of the waterway transport into account. So I suppose at end of my presentation, I would like to show you 3 typical applications and experiments we have done based on the research of the RAS lab at Delft. So here we see the application of the platooning of fleets, or the leader and follower control principle to control the multiple ships which are distributed in the scale of the waterway transport. So based on this control principle, that means we build the communication in between the leader and the follower, then the collaboration in between 2 vessels will be realized. Then the second application, so here I just show you some simulation results based on the decentralized control of multiple autonomous ships. So based on this simulation, the control system take the path planning and the navigation trajectory and also the collision avoidance into account. So actually, besides this simulation output, the control system was also validated and realized in the Green Village I mentioned a moment ago with the multiple ships. And the third application is the formation of the ships as the fleet. So here I would like to show you the part of the research regarding the assembly of multiple ships and also the unique or consistent performance of multiple ships based on the hybrid control system. Okay, so I would say it's almost time. Due to the limited time, I'm sorry, I can't really introduce more about our research and also the project. So hopefully we have some other chances to really exchange ideas.
Yeah, thank you very much for Dr. Pang for the wonderful presentation on autonomous ship. It's last year we also invited MIT sensor lab talk about a robot in Amsterdam. So it's a very nice to see you again in the follow up. So just a quick question. For that project, your lab provide a control system for the each individual ship, right?
You mean the project together with the MIT?
Yes.
Yeah, actually, we didn't really distinguish the tasks for each site because 2 years ago, we had a new colleague graduated from MIT. And now she is the assistant professor within our group. So that's reason, yeah, since 2 years ago, we had a very close cooperation with MIT in the field of autonomous shading.
Okay.
So, yeah, so most of, besides the robot was developed by MIT, and also we developed the control system together and applied for both the robots and also our Delphi.
I see. So in the last animation, when you have a 3 ship move together, you said it's a hybrid control system. I assume that's both remote control and autonomous on ship control, right?
Yeah. So for the hybrid, I would say the overall control structure can be distinguished as 2 layers. The lower layer is kind of agent-based. That means each agent of a single ship controls its own maneuvering. Then the agent communication among those individual ships forms the distribute control to let them know each other, communicate with each other, and the overall control is done by the higher level as the centralized.
We by the high level, that's a human made decision, right? At the high level.
No. Now everything is autonomous.
Oh, everything's autonomous. Okay.
Yes. So that's also the onboard intelligence we equipped on the 1-ton ship from the University of Leuven. Now we are able to achieve the autonomy as the level 3.
Oh.
The decision is fully made by the intelligence on board, but the operation is monitored by the human driver.
Okay, the monitored by human driver.
Yeah, so actually the latest 3 examples I showed you, everything are in autonomy.
Oh, wow.
Without human interference.
That's very nice. So I assume you have a LiDAR on board and also has 3D camera on each individual boat, right?
Yes, we have a GPS for outdoor application, and we have camera for indoor positioning, and we have a distance sensor, gyro, accelerator.
Okay. And each boat has a Jetson computer or like what kind of computer you put on each boat like that?
Yeah, that's very simple. If I'm not sure I need to. Okay, the CPU is named as ARM Cortex.
Okay.
Yeah.
Okay. So
very tiny CPU. Yeah.
Because we are building on surface like deliver robot, we have to put a actual computer on board to drive the graphic and then.
Actually, the CPU I mentioned a moment ago, that's for the model scale ship.
Oh, okay.
For the later on the 20 tons real ship, the one German company is developing the control system. That will be a real computer system to realize the control.
For all this boat, you said it's a zero emission, so they are all electricity powered boat.
Yes. Yes. Yeah. No fuel applied.
Okay, so it's a zero emission and autonomous boat.
Yeah.
I was curious, like how the, like you list a lot of individual company and 3 major universities, how the collaboration work. Because in the US, like once you get a grant, it goes to the university, it doesn't go to the company. How the European model work?
Okay, how to say, just like this project, at the beginning, we have one organizer to initialize this project. Then we get, we just collect the partners who are interested in this project. Then we write a proposal to apply for the EU funding. Actually, during the proposal stage, we have already split different work packages. And for each work package, we have the package leader. Then the package leader will lead this package, then to communicate with the relative partners to get support of them to realize the tasks of each package.
So the individual company can also be a package leader, like
yes. For instance, currently the development of the 20-ton vessel is led by 2 German companies.
Oh, okay, that's
located in Hamburg. But they only built the electric-driven vessel. So for the control, they don't do that. Then the control system will be realized based on the learned technology from our model scale vessel and also the 1-ton pilot vessel.
Wow, that's very, very good. Very like, because we can, in the US, most people can only hire companies, subcontract.
Yes, the interesting thing is I realized in your group, I suppose you have a lot of Chinese students.
Yes.
Yeah, I suppose the project is performed in United States more or less the same as in China.
Yeah. Similar.
I would say the project in European countries, especially for the EU funding, it's a little bit different.
Yeah, that makes sense. Very good. Any other questions from the audience for Dr. Pan? So, well, if no more questions, let's give another round of applause to Dr. Pan for his wonderful talk. It's very enjoyable, and I learned a lot. And I'm sure we're gonna have a lot of collaboration in the future.